How to create a PCB design for a RAK3172 based LoRaWAN end device using KiCad for long-range IoT applications. RAK3172 is one of the most popular LoRaWAN modules on the market. Priced at just $5.99 per piece, it is an excellent choice for LoRaWAN device hardware developers. Not only does it support standard AT commands, but it can also run independently using RUI-free, meaning you won't need an external host MCU. In this how-to guide, you'll learn how to design a LoRaWAN device PCB using KiCad with RAK3172 as the main LoRaWAN module without an external MCU. This tutorial can serve as your starting point for building custom LoRaWAN devices from scratch. Let's jump right in. Installation of KiCad version 9. KiCad is an open source EDA tool for schematic and PCB design that is gaining popularity among engineers. In this how-to guide, we will explore how to create a PCB design for a LoRaWAN device that utilizes RAK3172 as the LoRaWAN module using KiCad. If you do not have KiCad, download it from the link, then select the right installer based on your operating system. Getting KiCad files for RAK3172 from Snapmagic. You can skip this step if RAK3172 is already added in the KiCad version you use to create a PCB design for RAK3172. You need to have the schematic, symbol, and footprint layout for the RAK3172 LoRaWAN module. You can download the compatible files from Snapmagic, formerly known as Snapda. Here's a quick link where you can get the files. It includes the schematic, symbol, PCB, footprint, and 3D step file. You need to select the correct EDA software and version, which in this case is KiCad. You have to download these files and store them on your own PC. You might need to create an account in Snapmagic to download these design files for free.
Adding the schematic drawing and PCB layout to KiCad.
Adding the schematic symbol and PCB footprint on KiCad is not difficult, and there are different ways to manage your added files. It can be based on project design, etc. But whichever way that works for you and your team is out of scope on how to do this, we will keep it in one location to keep the tutorial simple to follow.
You have to open KiCad and click on Preferences. From here, you can add the schematic symbol of RAK3172 LoRaWAN module under Manage Symbol Libraries and the PCB footprint.
Designing the schematic. After saving the files on designation locations in your PC, you can proceed on designing the schematic of the RAK3172 LoRaWAN module, which requires you to navigate KiCad using its navigational tools. Lots of panning, zooming, copy-paste, deleting, wiring, etc. We will not be able to discuss each of these steps, but the full how-to video will be able to demonstrate the step-by-step process on creating the schematic design, including adding values to the components and annotating the parts. We will explore what are the considerations to take note when designing a custom LoRaWAN and device board for your IoT LP1 applications. 1. Ensure that the reset pin has a bypass capacitor. The capacitor ensures that there is a stable signal on the reset pin. Without this capacitor, the RAK3172 will be susceptible to external influences which can cause unwanted resets. If the RAK3172 LoRaWAN module will be deployed in a noisy environment, you might need to add an extra capacitor in this pin with a different value to complement the resonant frequency of the 100 nanofarads that is commonly used. Second, UART2 of RAK3172 LoRaWAN module is the most important pin out of this LoRa module. UART2 serves two purposes. It accepts the AT commands and it is used for FW updates. Without a UART2 header or connector, your RAK3172 schematic design will be very weak. It cannot accept AT commands and it cannot accept any FW update. 3. Related to UART2 headers, it must include the boot pin and it must be connected beside the VDD level. If you are doing an RUI-free FW update, a boot pin is not needed. However, if you need to perform a full chip erase or need to upload the complete .hex file to your RAK3172 LoRaWAN module, you will need the boot pin to be pulled up, then use STM32Cube Programmer. We have a complete guide on how to use STM32Cube Programmer for RAK3172. This guide is very useful in scenarios where RAK3172 got bricked or went to a condition where you cannot use the UART2 RUI-free bootloader to update the FW. 4. Another important connection that is related to interfacing to the board is the SWD connections. This allows you to connect debuggers to RAK3172 like ST-Link, J-Link, or RAK-App1. It is also advisable to include reset on this connection. 5. Do not connect anything on PB12. This pin has a special internal function where it determines if the RAK3172 LoRaWAN module is for the low frequency variant.
6.
it is recommended to make UART1 accessible. One approach that you can do if you use the RAK3172 as an external LoRa or LoRaWAN modem with external MCU is to reserve UART2 for FW update and UART1 solely for AT commands. UART1 by default does not accept AT commands, but it can be enabled via custom firmware using Serial API. After all these considerations, your schematic diagram for the RAK3172 LoRaWAN module is now ready. Here's the complete schematic for your reference. Creating the PCB layout. Since the PCB footprint of RAK3172 is now added on KiCad, you can double click on the RAK3172 schematic symbol and configure the footprint field. You have to navigate on the location of the footprint file, rak3172.kicad mod. The file extension of PCB footprint in KiCad is KiCad mod, while the file extension for the schematic symbol is KiCad sim. You must click the switch to PCB editor to start your PCB layout work. Doing this will link the schematic design to your PCB layout. This will also allow you to move back and forth from schematic to PCB layout and vice versa. From here, you can start on your PCB layout. Step-by-step layout is not on this guide, but all the process can be seen in the full video tutorial. Generation of manufacturing files. Once the PCB design is finished, it is easy to generate the drill files and Gerber files needed by the PCB manufacturer. You only need to click on File and Fabrication Output. From here, you can have different selections of what production-related files to generate. You need to select Gerber files. On Gerber's menu, you also need to generate the drill files. These generated files will be saved in a folder you selected. This is the folder that you will compress into .zip, which will be used for the PCB fabrication. Uploading Gerber files to PCB manufacturer like JLCPCB. Once the zip file is generated, you can now use these files as production files to your PCB manufacturer. For example, in this guide, we are using JLCPCB. If all are okay, you should be able to see the PCB design that you created by putting the zip file to the PCB manufacturer website. It is very common that you only need to drag the zip file or the raw Gerber files to the website, and you can immediately see a preview as well as an estimated cost. And that's it. Here is a quick recap of what we did. 1. Installed KiCad version 9. 2. Downloaded RAK3172 symbol footprint and 3D files from Snapmagic. 3. Added those files to KiCad libraries. 4. Designed the schematic and PCB layout. 5. Generated Gerber and drill files for manufacturing. Now you've got a solid starting point for creating your own LoRaWAN PCBs. If you found this helpful, give it a like, hit subscribe and check out the full tutorial for all the step-by-step details. Thanks for watching and I'll see you in the next one.